Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are looking at the basics of electrostatics. The first thing we should do is know our definitions. The first definition is Coulomb's law, which is very popular and it is very important to electrostatics. If we read, Coulomb's law states that the magnitude of the electrostatic force between two charges is directly proportional to the magnitude of each charge and inversely proportional to the square of the distance between the charges. And this is a very famous equation that we must use. F is equals to K Q1 Q2 over R squared. Don't forget the square of the denominator of the distance between them. And K is the electrostatic constant, which we know as 9 times 10 to the power 9 Newton meter squared per Coulomb squared. So that is the first definition that we have to know. The next definition that we have to know is electric field or electric field strength, and here we see that we are given the electric field is defined as the force experienced per positive charge placed at a point. Now, this is also a definition of electric field which you should know very well. What this means is that, say we've got a positive sphere, like in the case here, the diagram at the bottom, Q, and if you place a positive test charge at this point and it's positive, then what would happen is, because the original sphere is positive, it will repel this positive sphere outwards. So what we can see is that they may ask us to draw the electric field pattern of a positive sphere or the electric field pattern of a negative sphere. The only difference is, for a positive sphere we have lines radially going outwards, and for a negative sphere, a negatively charged sphere, we have radial lines going inwards. Now going further, if we have an example where they can ask us that if we have two charges, one positive charge and one negative charge, and they are brought near one another, and they can ask us in the exam to draw the electric field pattern of these two charges, then the diagram should look something like this, where we see that the field lines go out of the positive and into the negative, and we have the shape as the picture is, and usually they give it for 3 marks. Then we can see the criterion. I've taken this from a memo of one of the papers, where firstly they give a mark for the direction, that means out of the positive and into the negative. They give a mark for the shape, where the shape must look like the diagram above. And thirdly is the field lines must not touch each other. For example, many a times we see learners drawing a diagram where the field line is drawn like that, and then another line is drawn like that. Then we see that because they are touching here, you are not going to get the marks. It's unnecessary wastage of marks. So you should be very careful of losing marks. Um, uh, for that, it's a simple diagram and it is easy to learn. So let's not waste marks in the exam. Going further also, we can see that they can ask a question that in the case where we have like charges, two positive charges or two negative charges. And when we have two positive charges, then if they ask us to draw the field pattern when the two are brought near each other, then the field pattern will look like this. The shape is important, the direction of the field lines, and we must make sure they are not touching. To make it easier, it is better to draw larger spheres rather than smaller spheres, so we can ensure that the lines don't touch when we are drawing the diagram. And then if we have parallel plates, we see that parallel plates, we have field lines that are equally spaced, and it goes from the positive sphere, positive plate to the negative plate. The positive plate doesn't have to be placed on the top, and the negative plate does not have to be placed at the bottom. And we see that we have a uniform field where the electric field strength is constant throughout the field. Okay, going further, another question that they can ask us is that if we have two spheres that come into contact with each other, and then separate to the original distance between them, they want to know, calculate the new charge between the plates. So let's take an example. Say we say this is 4 microcoulombs and this is say minus 8 microcoulombs, and the distance is maybe 2 centimeters apart. In this case, the centimeters doesn't matter. So we have, if you want to work out the new charge between these plates, then the equation that we will use is Q1 plus Q2 divided by 2. And in this case, we see that we got 4 microcoulombs, so it's 4 times 10 to the minus 6, and then it will be plus, and then you put the minus 8 microcoulombs, and you divide it by 2. And if you take a calculator and you work this out, we're going to get minus 4 divided by 2, and it gives you minus 2 times 10 to the minus 6 coulombs. So that will be the charge on each of the spheres between these plates after they come into contact with each other. So now we can say that the spheres do have new charges, and this sphere has a charge of minus 2 microcoulombs, and this sphere will have a charge of minus 2 microcoulombs. They will have equal charges because once they come into contact with each other, the charges are distributed equally. Now, another question they can ask us is determine the number of electrons that moved over. So to do that, we can say that if you look at the change in charge that we had, that our final charge, Q final minus Q initial. Our final charge is minus 2 microcoulombs. I'm just going to leave it as microcoulombs. And my initial charge, we can choose anyone. Say we choose this one, right? That is our first charge is 4 microcoulombs. And if we work this out, we see that if we calculate it, it will be minus 2 minus 4 will give us minus 6 microcoulombs. The number of the electrons will be equal to the change in charge that we had divided by the charge of an electron. And if you look at this, we had minus 6 times 10 to the minus 6 coulombs divided by the charge of an electron is a constant, which is 1,6 times 10 to the minus 19. And if we take a calculator, we will be able to calculate that. And using the calculator, we see we get an answer of 3,75 times 10 to the power 13 electrons, and that will be transferred from the one sphere to the other. I can say that will be electrons. So this is a typical sum that you can get when you look at sphere charges that come into contact with each other. They can ask you to calculate the new charge. They can ask you how much charge is transferred, and they can ask you how much electrons have been transferred from the one plate to the other. So I will stop there for now. Thank you.